Only 1% of all of the water on the planet is fresh, usable water, and it's found in our lakes and rivers. I'm Alyn, and this is Stephen, and together we work for an organisation called CatchmentCARE, who study and look after some of our rivers. We set out on a journey to explore 3 rivers, the Arnie, the Blackwater and the Finn, and along the way we met some amazing people who are taking care of them, and some of them doing mind-blowing science to help them. We got to see some incredible places, some super sights and fantastic creatures. And most of all, we learned just how important our rivers are. Do you want to find out more? Then welcome to the river.
Hello and welcome back to the river. Today we're going to be exploring how rivers shape our landscape. Sometimes we think that rivers are just a way of moving a bunch of water from the source right down to the ocean, but we're going to discover that that's not always the case.
Yes, and we're also going to be speaking to different people who are going to help us understand how rivers forge and create these different features.
As we saw in our river stages, a river's course is not always straight, and to understand why, we need to look at the geology or the rocks beneath. The problem is, Stephen and I don't know much about geology, but Paul from BGS, or the British Geological Survey, does. So Stephen went down to Marble Arch Caves to see Paul and ask him how the river affects the rock beneath. And he started out by asking him, what is karst?
Well, karst is a unique type of rock formation which it forms whenever you have limestone, and limestone dissolves from water which is slightly acidic, and that means that the rock actually collapses down in. That allows more water to come down in through, and it creates these caves and caverns and conduits underground, and then that's where we can get rivers sinking down into the rock, and then they can actually flow through the rock, and then it'll appear and emerge as somewhere like this where you have...
Is that what's going on here?
That's what's happening here. This is karst, this is limestone, and the water has flowed the whole way through this for a few kilometres and is now appearing back out through the ground here.
Well, we've got a huge big cliff of rock here, and the river's flowing really fast alongside it. But I've got a question.
Yep.
How come the river is flowing right here and not 10 metres up direction?
That's a really good question. At the minute we know that the river flows here because this is the lowest part on the ground, but a long time ago this wouldn't have been the lowest point in the ground. But generally what we know that rivers will always take the path of least resistance. It's a bit like whenever you're trying to come out of maybe a busy stadium, something like that, you're always looking for where's the quickest place to go. And often that is where there's weakness in the ground, where there's weakness in the rock, and the water will tend to go down through that. And as the water goes down through it, it takes away parts of the rock, and then it becomes bigger and deeper and steeper until you end up with what we have here. We can see over on this side that we have 2 different types of rocks. Again, that gives you another weakness. So again, the water will flow where there's weaknesses in the ground, and that's why it's here probably, rather than further over that way or the other side.
As we saw in our water cycle, water can make its way to the river in lots of different ways. So we asked Paul what the difference between groundwater and rain runoff was.
Okay, so runoff is what happens whenever you have rainfall events, and then water goes over the surface of the ground, and then it gets into rivers generally fairly quickly, within a matter of minutes and hours after you've had rain coming through. Whereas groundwater is the water that seeps down into the ground, so it's a fairly large proportion of what lands on the ground actually goes down into the ground. It's a bit like whenever you're on the beach and you're building a sandcastle, one of the things you have to do is you have to put a moat around the outside of the sandcastle and then run down to the sea with your bucket, come back up and fill it full of water. But the problem is every time you run back, the water disappears. It just seems to go somewhere. And where it goes is it goes down into the ground through the grains of sand, and that's exactly what happens across the whole of the ground surface. Water goes down into the ground, and that water forms these large basins of groundwater that then slowly flow down towards rivers, and eventually that water comes up into rivers to keep them flowing during especially dry periods.
So I wanted to understand more about the connection between rocks and a river, and so I went down to Marble Arch Caves to meet Chris Finlay to ask him how it all works. Now, it had been raining the day before, so I couldn't get into the caves, but last year some of our schools got to go down and explore the depths. So look, Chris, you've brought us to this big lump of rock. Why on earth have you brought us here? I don't see any river, I don't see any water. What is going on?
Yeah, it's a bit of a strange one.
Okay.
But here at the Marble Arch Caves, what we can do is we can actually look above ground to tell us about what's happening below ground. And this just happens to be one of the perfect spots to do it in Cladaglen. Because if we look behind us here, what we've got, I know it just looks like a huge lump of rock, as you said, but if we look a wee bit closer at it, there's some kind of like features or characteristics of it that tell us a lot about what's happening above ground, but also the potential of what can happen below ground.
Okay.
So if you look a wee bit closer, can you see kind of the lines going across, those horizontal lines in the rock?
Yeah.
So those are what we call kind of bedding planes. And those form because limestone is a sedimentary rock.
Okay.
And when it formed millions of years ago, in this case, our dark tree limestone, about 320 million years ago.
It's a long time ago.
Yeah. It formed at the bottom of a shallow tropical ocean.
Okay.
And calcium carbonates, that would be from like dead kind of like skeletal parts of shells and bones of animals, sunk to the bottom, and over time they built up in layers.
Okay. And then, so that's the rock, but there's still no water. Where does the water come into all of this?
The water comes into it because limestone is actually a soluble rock, and, and water has the ability to react with it kind of at a chemical level. And we can see how that would happen when we look at this big slab of limestone.
Okay.
And because with those bedding planes, those horizontal bits, and the vertical faults, which are the kind of the joints which go down, we can see how water could kind of make its way into the rock.
Okay.
And when that water enters the rock, it reacts with it, and it actually dissolves the limestone.
So it's like if you leave a piece of chalk out, if you've been drawn on the pavement and you leave your chalk outside, it sort of dissolves, it disappears.
Exactly. It would be just like water and salt.
Oh yeah, okay.
So it dissolves, and what you'd be left with is a watery liquid that's full of limestone.
Bits of rock.
Bits of dissolved limestone, and that is known as calcium bicarbonate. And it makes its way down through the cave system, and that's how they're formed.
As the water dissolves the rock, it leaves massive gaps and holes underground that we call caves. And over many years, some of the roofs of some of these holes fall down in. But the water carries on inside the caves and carries all the dissolved rock out of the cave system down towards the sea. So we're looking out over this landscape, and it is covered in these huge big limestone boulders, and it's a karst landscape, so we know that water's affecting it. How does water change all of this?
Well, you know, Alan, if we think about it, when we look at Culca, it's huge, and in Fermanagh we get so much rainfall. We get about 1,200 millimeters per year, so it's a lot. Where does all that water go? Well, Culca itself is a blanket bog, it's kind of like underlying geology of limestone rock with this big like lovely carpet of peatlands that are like lying on top. And what happens is that water which falls on Culca, it actually goes down pretty much through the soil and on its way downstream.
Yeah.
And picks up some like acidic properties from the peatland itself. And that makes the water, which is running kind of over the surface and underground, that bit more aggressive, so it's able to actually dissolve a lot more.
Okay.
So that's what we see happening kind of at the bog. But we also see kind of surface features that tell us that other things are going on underneath the ground.
Okay.
So we would see things like dolines, which is where we see depressions in the landscape, which is,
we saw one just over there, a huge big hole. It's covered in grass, like it just looks like a hole.
It does, yeah. And the analogy that I love is that it looks like, you know, a giants came along and just pushed their big huge finger down on the landscape.
Yeah.
It just looks like a big hole, doesn't look like much. But what it tells us is that underneath the ground there's stuff going on.
Yeah.
So the water itself is actually reacting and dissolving with the underlying limestone. And the land itself is reacting in the only way it can, which is to sump and to fill down to that.
So we're sitting on a landscape that is constantly shifting and moving all the time. Even the rock is being worn away.
Yeah, below our feet as we speak, there is changes and different processes that are happening that are like constantly dynamically changing. At this very moment, there's probably new passageways. It's very slowly, but they're beginning to open up. There's new networks of cave systems which are opening up beneath our feet right now. And it's hard to imagine because we can't hear or see them, but there is pumping rivers, subterranean rivers underneath us right now.
I've come back into the kitchen because I want to do another science experiment, two actually, because Paul and Chris have been talking about how the water takes on some acidic qualities as it flows through the bog, coming down off Culca Mountain and creating marble arch caves. But I thought acid was a bad thing. I thought if the water's got acid in it, that's a terrible thing. And it is a lot of the time. If it has like battery acid or acids that are used in chemistry labs, that would be a terrible thing because they can burn and, you know, they can leave you with real bad scars. But there's a lot of acids that we use all the time in our homes that aren't dangerous. Things like, well, what's your favourite flavour of crisps? Mine is cheese and onion. And I really don't like the ones in the blue packet, the salt and vinegar. But vinegar is acetic acid, and that's something that we can use safely all the time. Or some of the creams that you can now get for your skin, you know, hyaluronic acid, you know, it makes your skin hydrated and makes you look young, and I certainly need that. But there are some acids that are helpful to us. So I thought I'd come to the kitchen and try out 3 different liquids to see how acidic they were. Now, I've got some magic paper called pH paper. This is it here. And if I take a little strip of this and dip it in a liquid or put it onto something, it will tell me how acidic it is. If I have a look at my chart here, right up here is battery acid, which is really dangerous. So it was bright red, I couldn't touch that. Then it goes right away down to sort of yellow, which is water, and then all the way down to sort of a purple on the other side, which is a drain cleaner, which is an alkaline. In the middle, somewhere around here, you've got things like milk and seawater and eggs and things. So my little piece of paper, I'm going to dip it into some water first of all. Let's see, and it should come out, according to my chart, it should come out yellow, and it has, it's come out yellow. There we go, so that's pure water. Let's take another one. I have some milk here, so I expect it to go sort of a dark yellow or a green. Let's have a look. Dark yellow or green. It's kind of a dark yellow or a green. That's great. So yeah. But if I touch the vinegar with it, which is acetic acid, I'm expecting it to turn like a pinky colour or an orangey colour. Let's have a look. Yeah, it's gone pink. So we can tell that the vinegar is acidic. Okay, so one more. And this is a bit of an experiment now because I have a lemon and I'm not going to look at my chart. What I'm going to do is I'm going to cut the lemon. What do you think? Do you think that it's going to be acidic or do you think it's going to be neutral? Do you think it's going to be in the yellow scale or do you think it's going to be in the reds and oranges? Well, it's certainly quite bitter, isn't it? Let's see if I get some of the orange or the lemon juice. Like one of those goats in those videos. Blah, 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 blah. So let's just get some juice out here. And touch the lemon. What do you think? Let's see. Oh yes! It's gone bright pink. So let's have a look. Bright pink is way up here with orange juice and lemon juice. There it is, and vinegar. So it's the same sort of acidic qualities that vinegar has, which is why it makes you go blah, 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 blah. Okay, second experiment. This time it's your turn. What you'll need for this experiment is 2 glasses, some water, some vinegar, and a piece of chalk. Okay, go get it. Go, go, go. I'll wait here. Go. I'm waiting. Have you gone yet? Haha, you're back. Good. Okay, so I've got my 2 glasses. I have 1 piece of chalk, but I've broken it into 2 pieces. I have 300 milliliters of water, and I have some acetic acid, which is vinegar. Now, when Paul and Chris were talking, they were telling us that the water that came across the bog broke down or wore down or eroded away the limestone. I have chalk. Chalk is a different type of rock, but it comes from the same family of sedimentary rocks. So, into this 1 glass of chalk, I am going to put in 300 milliliters of water. Like so. Do you hear it? So it's working away on that chalk. However, I'm going to add I'm going to get another 300 milliliters of water. And this time I'm going to add in the vinegar. And it's gone slightly brown because I'm using malted vinegar. And I'm going to put my chalk in the glass. And I'm going to add in my vinegar water. Wow. Look at that reaction. It's immediately starting to dissolve. Look at that. It's going nuts. So there's a few bubbles coming off here, but in this one, it's going bananas. So you can see that perhaps over millions of years, how the acidic water would cover over the limestone or flow over the limestone and begin to wear it down. And just like here, it would create lots of little holes and then bigger holes and bigger holes and bigger holes as it eroded it away. And eventually it would wear down into the rock and create caves and karst systems that we saw in our last episode.
So much to learn in that episode. Isn't it amazing how geology and rocks are affected by the water and rivers, and how the rivers are affected by the rocks and the geology? Think of all those caves and all those karst features that we learnt about today. Join us next time to find out how people are affected by rivers and how people affect rivers.